Hello, my name's Todd Miranda, and in this video I'm going to demonstrate how to use path markup language to define a path. So one of the things that we can use to define a path, and technically is to define the geometry of a path, is path markup language. And this is also called a path mini language as well. And the bottom line is, sometimes when we look at path markup language, it can be very confusing, it can be a little intimidating. So let's take a look at exactly what I'm talking about. I'm going to open up Expression Blend, which I've done here, and I'm just going to create a very rudimentary path, so nothing too terribly complex. This will give us the capability to just see exactly what we're talking about. So this is a path that has some curves in it. Again, nothing too terribly complex. Well, let's go look at the XAML for this path. When we go look at the XAML, we have our path, and we see that the geometry of the path, which is defined by the data property of the path, contains this long string of mostly numbers with some letters thrown in here and there. So you see, as we look down here, we can see what looks like points. So we've got what looks like X and Y coordinates. And every once in a while, we've got a letter thrown in. So you see, we've got some L's, some M's, some C's. And when we look at this, this can be a little intimidating. It can be a little confusing sometimes as well. What do all the numbers, what do all the letters mean? Well, that's what we're going to try to take a look at in this particular demonstration. So let's create a new project. And we're just going to create a WPF Windows application project. We'll name it accordingly. And we're going to, when our project comes up, we're going to decrease our design space a little bit to give us some more space in our XAML view. And I think we can probably shrink that down a little bit. And let's just make our window a little bit wider. So we'll make our path to be more wide than it is high. Okay, so let's just begin by creating a path element. And we'll specify that its stroke is blue. And maybe the stroke thickness is, let's say, 2, so we can see that pretty well. And then we'll come in and specify its data. Okay, so now let's take a look at the data element, which defines the geometry of the path. And let's write the path markup from scratch, so we can take a look at the different types of elements that we've got, the different types of markup elements that we've got, and how those behave, and how to code them. So the first thing that we need to do is we need to use a move command. So move command begins with an M, and this defines the starting point for a particular path segment. So in this case, let's just start it at an arbitrary 30, 30. So that's 30 along the X, 30 along the Y. Now obviously you don't see anything visual here, and that's simply because the M, or the move command, simply does just that. It says move to this location. Might seem a little strange. Why would we have that? Why don't we just have some kind of a start point? Well, if you've got a compound path that's made up of individual single paths, you might want to start a path, draw a couple of segments, and then you might want to move to another point instead of drawing a line from the end point to the beginning point of the new segment. We may want to just pick the pen up, if you want to look at it that way, pick the pen up off the paper, move it to a new location, and then put it down to begin drawing again. And that's where move really comes into play when you've got a compound path. So we start our path geometry with a move, which gives us the start point of our segment collection. So the next thing that we want to do is let's look at two of the most simple of the segments that we've got, and the first one of those being a vertical segment. So V is for our vertical segment, and obviously we know vertical is just a line that goes north-south, that goes up and down. And let's go down to V75. So when in path markup language, the start point for a segment is the ending point of the previous segment. So our previous segment was a move command, or a move segment, if you want to look at it that way, begins at 3030. So this becomes the start point of our next segment. And a vertical line just simply takes one number. It takes the new y value of the point. So we said 75, which moved us down another 45 in the y direction. All right, so the next segment that we want to take a look at is a horizontal segment. So we'll do H for our horizontal segment, and let's do the same thing. We're going to move this over to 75 on the y axis. So the begin point was the end point of our previous segment, and now we want to go to the end point of our horizontal segment, which just simply means we want to move to the 75 position on the x-axis. Okay, so far so good. So let's look at another type of segment, and this other type of segment we'll look at is a line segment, which begins with an L. So notice some of these make sense. We're going to get to some that the letters may not necessarily be as intuitive, but so far they have been. So a line segment is just that. It draws a straight line from the end point of the previous segment, which becomes the start point of the line, to the point that we want to specify after the L. So in this case, let's just go to 100, 100, which isn't something easy to work with. So we've drawn a line to the point 100, 100 from the point we were previously at, which happened to be 75, 75, because we moved to the 75 on the y and the 75 on the x. Okay, so far so good. Everything seems to be relatively easy to follow. Now, for the remainder of these types of segments, we're going to take a look at some of the different types of curve segments. And one of the things that makes it easy to kind of follow along with that is if we create another path, and this time we're going to stroke this one with a red stroke, leave the stroke thickness at 2, and we're going to leave the same exact segments in place. All right, so what that enables us to do is you're fixing to see how we're going to be able to utilize this. For now, let's draw a line segment. All right, from 100, 100, we're going to go to, let's say, 150 on the x, 50 on the y, and then we'll draw another line segment that goes to 200 on the x and back to 100 on the y. Okay, so you see what we've done is we've created this this kind of a little bit of a triangle, all right, or an arrow if you want to look at it that way. So the reason we did that is because now we're going to look at our first curved segment, and our first curved segment is the quadratic Bezier curve. Luckily, it's a pretty easy one to remember. It begins with a Q for quadratic Bezier curve. And the quadratic Bezier curve takes 2 points. It takes a control point and an end point. We already have the start point, because remember the start point is the end point of the previous segment. So we have a start point, a control point, and an end point. Here's our start point. And in this case, our control point will be 150, 50. All right, so hopefully now we see how we're going to utilize some of this. And then our end point will be 200, 100. Okay, so this is the real curved segment. All right, and a quadratic Bezier curve, as I said, takes 2 points, a control point and an end point, and it forms this nice curve here. So why did we draw this line here? Well, the way that a quadratic Bezier curve works, and we're not going to really get into the mathematics of this, so since we're not going to talk mathematics, let's just talk generalities. And as a generality, if you draw a straight line to the control point and then to the end point, which forms this nice little point, a quadratic Bezier curve will live inside of that, inside of this angle. So you see that we've got those 2 points defined here. Our quadratic curve lives nicely within that angle. All right, so it's just a good way to help visualize our curves and how the points play into what the curve finally looks like. Okay, so let's take and go up here to our control. We'll call this our control lines, and let's just go to 250, 150, and then we'll draw another line to 300, 100. Okay, so you see where we're going with this. Now we've drawn just the opposite angle here. So let's put another quadratic Bezier curve, another Q, and we'll follow our lines. So 250, 150, space 300, 100. Okay, so now there's one thing that I want to show here, and in order to do that, I'm going to come in and I'm going to set the visibility on our control path to hidden. All right, and actually that in design view we'll still see that, so I'm just going to cut this path for now. All right, so if you look really close here, and we'll zoom in, we have a relatively nice transition between those two curves, but oftentimes that's not the case. So if we change this just ever so slightly, where maybe we go to 250, 140, now you see that we've got a little bit of a break there. Maybe it's not quite as evident, so perhaps instead of this, maybe we make this a much more dramatic break. All right, so you see that little crook right there between the two curves. Well, you know, what if we want a nice smooth transition between those two curves? All right, there's a way to do that. So let's throw back in our control, except we're going to change our control to match what we did here. So we went to 200, 200, and you can see that even though we changed our triangle, our quadratic Bezier curve still fits nicely within the angle. So let's take a look at how we smooth this out. All right, and we do that with a smooth quadratic Bezier curve. So this is the first one. This is the first curve that we're going to get to where the abbreviation for it is not quite as easy to remember. So instead of this being another quadratic Bezier curve, we're going to change this to a smooth quadratic Bezier curve, and the letter that we're going to use to represent that is a T. All right, so we've got a smooth quadratic Bezier curve. Now, the smooth quadratic Bezier curve takes only one point. It only takes one control point, and the control point that it takes is just the end point. All right, so let's take a look at how that really works, because we know that we need, for a quadratic Bezier curve, we need a control point and an end point. Well, the control point on a smooth quadratic Bezier curve is assumed to be the reflection of the previous point from the last control point to the end point. So the line formed from the last control point to the end point, its reflection is assumed to be the control point. So let's take a look at what that really looks like. All right, so this line here goes from 150, 50 to 200, 100. So its reflection then would be 250, 150. Oops, not 1500, 150. So this line here is the reflection of this line here. So this is the control point that is assumed, and this is the end point. So all we have to do is specify the end point. This control point is assumed for us, and that creates our smooth quadratic Bezier curve, which is a nice transition from the previous quadratic Bezier curve. Alright, so far we've got our move, our vertical, horizontal, our line, our quadratic Bezier curve, our smooth quadratic Bezier curve. Now let's take a look at our cubic Bezier curve. Alright, so let's first of all, we'll go to our control, and we'll draw the lines that will be our control for our cubic Bezier curve. Alright, so a quadratic Bezier curve takes 2 points, a control point, and an end point. A cubic Bezier curve takes 2 control points and an end point. So let's try to do something a little bit, a little bit fun here. Let's go 275 on the X, and then we'll go perhaps 75 in the Y. And then we'll do our next control point will be, let's go back to 300 on the X and 50 in the Y. And then let's say that our end point will be 400 on the X and 100 in the Y. Okay, so here's our 3 points, which will map to 2 control points and an end point for our cubic Bezier curve. Alright, so let's expand our area here a little bit so we can see them all. So our cubic Bezier curve is a C, and we'll start with 275, 75. We'll do our second control point at 350, and our end point is 400, 100. Okay, so again, without getting into the mathematics of this, we see that our cubic Bezier curve nicely fits within the confines of our, if you want to look at this as almost a rectangular region, or some type of a parallelogram, or a quadratic type control or shape. So we begin here, and our curve fits inside of here, kind of corresponding to the dimensions and the shape of our little squared off region here, or rectangular region that we created. Alright, so there we have our cubic Bezier curve, and just like we have with the quadratic Bezier curve, we have a smooth cubic Bezier curve, and the smooth cubic Bezier curve works similarly to the smooth quadratic Bezier curve in that the first control point is assumed, and it's assumed to be the reflection of the line that would be formed from the end point to the last control point of the previous cubic Bezier curve or quadratic Bezier curve. So you can have a smooth cubic Bezier curve that comes after a quadratic Bezier curve. Doesn't have to necessarily be 2 cubic Bezier curves. So let's look at those lines. Okay, so let's do our reflection. Our reflection of that previous line would sit at 500, 150. Alright, so there's our reflection point. Well, let's go back the other direction. So let's go to maybe 475, 175. And then our last point will be, let's go 300, 150. Alright, so you see here's our new square. Doesn't have to be necessarily symmetric with the previous square. So let's take those same points and let's do our smooth cubic Bezier curve, and we'll start with our 500, 150. Actually, that's not the one we specify. That's the reflection. So we'll go 475, 175, and 300, 150. And you see that we get our smooth transition point here, and we stay within the confines of our rectangular region to form our smooth cubic Bezier curve. So then we can come in here, we can eliminate our control path, and there is our path that we have created using path markup language manually. And even though it looks like a fairly complicated path, we can see that it's fairly simple to understand once we have a good concept of what each of the types of path segments are and the control points and endpoints that go along with those.